Ok, super. Merci beaucoup à tous et toutes d'être venus. C'est toujours sympa de commencer avec un micro dans les mains le jeudi matin à 9 heures. Je vais faire une introduction en français d'abord. So I'm going to start with French for like 5 minutes. I promise it's only going to be 5 minutes, despite the myth that we cannot speak English or stop talking in French. And then I have some questions for Stuart. I think that's going to last between 25, 30 minutes. And then whatever questions you have, we'll be happy to take them. Voilà, donc bienvenue. Comme vous le savez, je m'appelle Ima. J'organise une série de petits déjeuners que j'ai appelé Safety Breakfast, donc petit déjeuner sur les enjeux de sûreté et sécurité dans le cadre du sommet qui se tient en France à Paris le 10 et 11 février prochain. Le but de cette série, c'est d'ouvrir un espace de discussion entre experts et passionnés des sujets de sûreté et sécurité de l'IA, de gouvernance de l'IA, pour que, au fur et à mesure du sommet, on se pose ensemble des questions et qu'on puisse tout simplement discuter de la manière la plus ouverte possible. Donc je sais que vous voyez une caméra, ne vous inquiétez pas. La partie questions ne sera pas publiée. C'est simplement les questions que je pose à Stuart et donc les commentaires et les réponses de Stuart qui seront publiées. Je vous enverrai évidemment le blog post et le transcript. Voilà. Donc, s'agissant du sommet sur la sécurité, comme vous le savez, c'est le 10 et 11 février prochain. C'est le 3e sommet sur la sécurité. Il s'appelle Sommet de l'action. Parce qu'on a une vision française qui est extrêmement ambitieuse et qui a pour objet de mettre en avant des solutions notamment par exemple des standards sur les enjeux qui sont afférents à l'IA, et donc pas seulement les enjeux sur la sécurité et la sûreté, mais vraiment des enjeux qui sont relatifs à l'impact sur le travail des systèmes d'IA, des enjeux qui sont relatifs à la gouvernance internationale, les enjeux qui sont relatifs à la façon dont on vit en société de manière générale, donc tout ce qu'on appelle AI for good, les systèmes d'IA pour le bien-être de l'humanité et évidemment en partie les enjeux de sécurité sur lesquels nous, AFLI, avec évidemment les enjeux de gouvernance, on se concentre. Voilà. Je crois que c'est tout. S'agissant du contexte par rapport à ce petit déjeuner et le sommet de manière générale, la prochaine édition du petit déjeuner sera début septembre. Ensuite, on aura une autre édition mi-octobre. Et si vous êtes intéressé, vous avez un QR code sur le côté. N'hésitez pas à indiquer votre intérêt sur une liste et puis je ne vous spammerai pas. J'étais avocate avant en droit humain et en droit des nouvelles technologies, donc le RGPD, je connais. Ne vous inquiétez pas. Voilà, vous ne recevrez aucun spam. On respecte le consentement des personnes, mais donc si vous voulez être invité, il faut, euh, il faut, euh, il faut nous l'indiquer, quoi. Voilà, that's it for the French. Thank you for everything. Again, thank you so much for coming. I know it's 9 a.m. I'm tired. You all are. But I really appreciate you coming despite the Olympics. And I really, really, really look forward to an insightful discussion with Stuart that I cannot thank you enough because he's here today. So, Stuart, thank you so much. I have. Do you want to say a few things before we start, or can I just dive into it with the questions?
Please dive
Yeah,
in.
can I?
And
Okay.
and congratulations to France on winning their first football match last night.
All right. So, Stuart, I know, we all know here, we've seen a remarkable advancement in AI across various domains, right? This includes improved models like GPT-3 and GPT-4, sorry, and Claude 3, more sophisticated image generators like DALL-E 3, video generation capabilities with Sora, and even progress in robotics and molecular biology prediction. Two notable trends that we've seen are the integration of multiple capabilities into a single model, so what we call native multimodality, and the emergence of high quality video generation. From your perspective, which of these recent developments do you consider most significant? And what potential challenges or implication do you foresee these advancements posing for society?
Uh, So these are quite difficult questions to answer, actually. And it might be helpful. I know, like Raja, for example, has perhaps an even longer history in AI than I do. But for, but for some people, who have come to AI more recently, the history actually is important to understand. So for most of the history of AI, we proceeded like other engineers, like mechanical engineers and aeronautical engineers. We tried to understand the basic principles of reasoning, decision making. We then built algorithms that did logical reasoning or probabilistic reasoning or default reasoning. We studied their mathematical properties, decision making under uncertainty, various types of learning. And we were making slow, steady progress with some, I think, really dramatic contributions to the human race's understanding of how intelligence works. And it's kind of interesting. So I think in 2005 at NeurIPS, which is now the main AI conference, Terry Sanowski, who was a co-founder of the NeurIPS conference, proudly announced that there was not a single paper that used the word backpropagation that had been accepted that year. And that view was quite common, that neural networks were not reliable, not efficient in terms of data, not efficient in terms of computation time, and didn't support any kinds of mathematical guarantees. And other methods, like support vector machines, which were developed, I guess, originally by statisticians like Vapnik, were superior in every way, and that this was just a sign of the field growing up. And then around 2012, as many of you know, deep learning came along and demonstrated significant improvements in object recognition, and that was when the dam broke. And I think it wasn't that we couldn't have done that 25 years earlier. The way I described it at the time was, we had a Ferrari and we were driving around in first gear. And then someone said, well, look, if you put this knob over there and go into fifth gear, you can go at 250 miles an hour. And so a few minor technical changes like stochastic gradient descent and ReLUs and other residual networks and so on made it possible to start just building bigger and bigger and bigger networks. I mean, I remember building a 7-layer neural network back in 1986, and training it was a nightmare because, because of good old-fashioned sigmoid activation units, the gradients just disappeared. And you were down to a gradient of 10 to the minus 40 on the 7th layer, and so you could never train it. But just those few minor changes, and then scaling up the amount of data made a huge difference. And then the language models came along, and in the 4th edition of the AI textbook, we have examples of GPT-2 output. And it's kind of interesting, but it's not at all surprising, because we also show the output of bigram models, which just predict the next word conditioned only on the previous word. And that doesn't produce grammatical text. But you go to a trigram model, so you're predicting the next word based on the previous two, you start to get something that is grammatical on the scale of half a sentence or sometimes a whole sentence. But of course, as soon as you get to the end of a sentence, it starts a new one and it's on a completely different subject and it's totally, totally disconnected and random rambling. But then you go to 6 or 7 grams and you get coherent text on the paragraph scale. And so it wasn't at all surprising that GPT-2, which I think had a context window of 4,000 tokens, I think it was. Tokens, yeah, so 4K. That it would be able to produce coherent looking text. No one expected it to tell the truth, right? This was just, can it produce text that's grammatical and thematically coherent? And it was almost an accident if it ever actually said something that was true. And I don't think anyone at that time understood the impact of scaling it up further. So it's not so much the context size, it's the amount of training data. People focus a lot on compute as if somehow it's the compute that is making these things more intelligent. That's not true, right? The compute is there because they want to scale up the amount of data that it's trained on. And the amount of compute is, so if you think about it, right, it's approximately linear in the amount of data and the size of the network. But the size of the network is linear in the amount of data. And so the amount of compute you need is going quadratically with the amount of data, right? I mean, there are other factors involved, but at least those basic things are going to happen. But it's scaling up the data set size that's driving that, that increase in compute. And so we now have these systems. So it's data set size, and then Instruct GPT was the first step where they did the supervised pre-training to teach it to answer questions. Because the purely raw model, is free to say that's a silly question, or I'm not answering that, or any other kind of thing, or even just ignore it completely. But if Instruct GPT, you're teaching it how to behave as a nice, helpful question answerer, and then RLHF to remove the bad behavior. And then we have stuff that, as I think OpenAI correctly stated when ChatGPT came out, it gives people a foretaste of what it will be like when general purpose intelligence is available on tap. And we can argue about whether it's real intelligence. So the reason I said it's a hard question to answer is because we just don't know the answer, right? We do not know how these systems are operating internally. When ChatGPT came out, one of my friends sent me some examples. Prasad Tadapalli is a professor at Oregon State. And one of them was, which is bigger, an elephant or a cat? And ChatGPT said, an elephant is bigger than a cat. You think, oh, okay, that's good. It must know something about how big elephants and cats are, because probably that particular comparison hasn't been made in the training data. And then he said, well, which is not bigger, an elephant or a cat? And it stated, neither an elephant nor a cat is bigger than the other. And so so that tells you two things, right? First of all, it doesn't have an internal model of the world with big elephants and little cats, which it queries in order to answer that question, which is, I think, how a human being does it, right? You imagine an elephant, you imagine a cat, and you see that the cat is teeny weeny relative to the elephant, right? If it had that model, it could not give that second answer. But it also means that the first answer was not given by consulting that model either, right? And this is a mistake that we make over and over and over again, is we attribute to the AI systems when they behave intelligently, we assume they're behaving intelligently for the same reasons that we are. And over again, we find that that's a mistake. Another example is what happened with the Go playing programs. So we assume that because the Go playing programs beat the world champion and then went stratospherically beyond the human level. So the best human is rating about 3,800. Go programs are now at 5,200. So massively superhuman. So we assume they understand the basic concepts of Go. But it turns out that they don't. That there's certain types of groups of stones that they are unable to recognize as groups of stones. We don't understand what's going on and why they can't do it, but now ordinary amateur human players can regularly and easily defeat these massively superhuman Go programs. And so the biggest takeaway from this is we've been able to produce systems that many people regard as more intelligent than themselves. But we have no idea how they work, and there are signs that if they are working at all, it's for the wrong reason. So can I just finish with one little anecdote? So I got an email this morning from another guy called Stuart. I won't give you his surname. And he said, I'm not an AI researcher, but I had some ideas, and I've been working with ChatGPT to develop these ideas about artificial intelligence. And ChatGPT assures me that these ideas are original and important, and it's helping me to write papers about them, and so on and so forth. But then I talked to someone who understands AI, and now I'm really confused. Because this person who understands AI said that these ideas didn't make any sense, or they weren't original, and well, who is right? And it was really shocking, actually. It was sad that a well-meaning, reasonably intelligent layperson had been completely taken in, not just by ChatGPT itself, but by all of the public relations and media explanations of what it is, into thinking that it really understood AI and was really helping him develop this stuff. And I think instead it was just doing its usual sycophancy, like, yeah, that's a great idea. So so the risks, I think, are of over-interpretation of the capabilities of these systems. It's not guaranteed that, well, let me rephrase that. It's possible that real advances in how intelligent systems operate have happened without our realizing them. Right? In other words, inside ChatGPT, some novel mechanisms are operating that we didn't invent, that we don't understand, that no one has ever thought of, and they're producing intelligent capabilities in ways that we may not understand ever. And that would be a big concern. I think the other risk is that we're spending, I think by some estimates, by the end of this year, it will have added up to $500 billion on developing this technology, and the revenues are still very small, like less than 10 billion. I think the Wall Street Journal this morning has an article saying that some people are starting to wonder how long that can continue.
Thank you. So speaking in terms of advancements and capabilities, we've been hearing about the next generation of models. OpenAI CEO Sam Altman has been hinting at GPT-5 for quite some time now, describing it as a significant leap forward. Additionally, we have recent reports suggesting that OpenAI is working on a new technology called Strawberry, which aims at enhancing AI's reasoning capabilities. The goal of this project would be to enable AI to do more than just answer questions. It's intended to allow AI to plan ahead, navigate the internet independently, and conduct what's being called deep research on its own. So this brings us to a concept known as long-term planning in AI, the ability for AI systems to autonomously pursue and complete complex multi-step tasks over extended periods of time. What do you think about these developments? What potential benefits and risk do you foresee for society if AI systems become capable of this kind of autonomous long-term planning? And maybe without pressuring you, in like less than 7 minutes.
Sure.
Thank you.
Okay. So I've been hearing similar things, talking to executives from the big AI companies that the next generation of systems, which may be later this year or early next year, will have substantial planning capabilities and reasoning capabilities. And that's been, I would say, noticeably absent, even in the latest versions of GPT-4 and Gemini and Claude, that they can recapitulate reasoning in very cliched situations where, in some sense, they're regurgitating reasoning processes that are laid out in the training data, but not particularly good at dealing with planning problems. For example, so Rao Kambampati, who's an AI planning expert and has been actually trying to get GPT-4 to solve planning problems from the International Planning Competition, which is the competition where planning algorithms are pitted against each other. And contrary to some of the claims from OpenAI, basically it doesn't solve them at all. But what I'm hearing is that now in the lab, they are able to successfully, robustly generate plans with hundreds of steps, and then execute them in the real world, dealing with contingencies that arise, replanning as necessary, and so on. So obviously, if you're in the taking over the world business, you have to be able to outthink the human race in the real world, in the same way that chess programs outthink human players on the chessboard. It's just a question of, can we transition from the chessboard, which is very narrow, very small, has a fixed number of objects, a fixed number of locations, perfectly known rules. It's fully observable. You can see the entire state of the world at once, right? So those restrictions make the chess problem much, much, much easier than decision-making in the real world. So imagine, for example, if you're in charge of organizing the Olympics, right? Imagine how complicated and difficult that task is compared to playing chess. But still, well, at least so far, we managed to do that successfully. So if AI systems can do that, then you are handing the keys to the future over to the AI systems. So they need to be able to plan, and they need to be able to have access to the world, some ability to affect the world. And so having access to the internet, having access to financial resources, credit cards, bank accounts, email accounts, social media. So these systems have all of those things. So if you wanted to create the situation of maximal risk, you would endow AI systems with long-term planning capability and direct access to the world through all of those mechanisms. So the danger is, obviously, that we create systems that can outthink human beings, and we do that without having solved the control problem. Control problem is, how do we make sure that AI systems never act in ways that are contrary to human interests? We already know that they do that because we've seen it happen over and over again with AI systems that lie on purpose to human beings. For example, when GPT-4 was being tested to see if it could break into other computer systems, it faced a computer system that had a CAPTCHA. So some kind of diagram with text where it's difficult for machine vision algorithms to read the text. And so it found a human being on TaskRabbit and told the human being that it was a visually impaired person who needed some help reading the CAPTCHA. And so paid the person to read the CAPTCHA and allowed it to break into the computer system. Right? So to me, when companies are saying, okay, we are going to spend $400 billion over the next 2 years or whatever to create AGI, and we haven't the faintest idea what happens if we succeed, it seems essential to me to actually say, well, stop, right? Until you can figure out what happens if you succeed and how you're going to control the thing that you're building. Just like if someone said, I want to build a nuclear power station. And how are you going to do that? Or I'm going to collect together lots and lots and lots of enriched uranium and make a big pile out of it. And you say, well, how are you going to stop it from exploding and killing everyone within 100 miles? And you say, I have no idea. That's the situation that we're in.
Thank you. So general purpose AI systems are making it easier and less expensive for individuals to conduct cyber attacks, even without extensive expertise. We have some early indications that AI could help in identifying vulnerabilities, but we don't yet have a strong evidence that AI can fully automate complex cybersecurity tasks in a way that would significantly advantage attackers over defenders. What happened last Friday? So the recent global IT outage caused by a faulty software update serves as a stark reminder of how vulnerable our digital infrastructure is and how devastating large-scale disruptions can be. So given this developments and concerns, could you share your thoughts on two key points? A, what new offensive cyber capabilities do you think AI might enable in the near future? And B, considering our reliance on digital infrastructure, what kind of impact should we be prepared for if AI-enhanced cyber attacks become more prevalent? Thank you.
So I'll begin by talking about that outage. Um, so it was caused by a company called CrowdStrike, which is a cybersecurity company, and they sent out an update, and the update caused the reboot process for Windows to go into an infinite loop. So it was a undergraduate programming error, and I don't have exact numbers yet, but just looking at the number of industries, including almost the entire United States aviation industry was shut down. Millions of people all over the world had their flights canceled, or they couldn't access their bank accounts, or they couldn't sell hamburgers because their point of sale terminals weren't working, and so on. And so if we said maybe it's $100 billion in losses.
Or they didn't have access to the healthcare they needed.
Yeah, I mean, so there probably some personal consequences that were very serious. So let's say if we, in monetary terms, 100 billion, give or take a factor of 10, caused by an undergraduate programming error, I mean, literally a few keystrokes. And if you read CrowdStrike's contract, it says, we warrant that our software operates without error. But our liability is limited to refunding the cost of the software if you terminate your license as a result of an error. So whatever, a few $100 refund for a few $100 billion of damage. To me, this is an absolute abject failure of regulation. Because even if they were held liable, which I think is quite unlikely given the terms of that contract, they couldn't possibly pay for the damage that they caused. And this has happened in other areas, right? So in medicine, there was in the 1920s, there was a medicine that caused 400,000 permanent paralyses of Americans. So 400,000 people were permanently paralyzed for life. And if you look at how that would turn out if it happened now in terms of liability, what kinds of judgments are happening in American courts, it would be about $60 trillion of liability. Right? That medicine maker could not possibly pay that. So liability simply doesn't work as a deterrent. And so we have the Federal Drug Administration, which says before you can sell a medicine, you have to prove that it doesn't kill people. And if you can't say, oh, it's too difficult, or it's too expensive. We want to do it anyway. The FDA will say, well, no, sorry, come back when you can. And it's long past time where we started to make similar kinds of requirements on the software industry. And some procurement mechanisms, so certain types of military software, do have to meet that type of requirement. So they will say, no, you can't sell a software that controls, bomb release mechanisms unless you can actually verify that it works correctly. There's no reason why CrowdStrike shouldn't have been required before they send out a software update that can cause $100 billion in damage, be required to verify that it works correctly. So and I really hope that something like that comes out of this episode, because we need that type of regulation for AI systems. If you ask, well, what's the analog of, in medicines, it has to be safe and effective for the condition for which it's prescribed. what's the analog of that? It's a little bit hard to say for general purpose AI systems. For a specific software application, I think it's easier, and in many cases, sector-specific rules are going to be laid out as part of the European AI Act. But for general purpose AI, what does it mean? Because it's so general, what does it mean to say it doesn't cause any harm or it's safe? I think it's too difficult to write those rules at the moment. But what we can say is there's some things that those systems obviously should not do. We call these red lines. So a red line means if your system crosses this, it's in violation. For example, AI systems should not replicate themselves. AI systems should not break into other computer systems. AI systems should not advise terrorists on how to build biological weapons. Right? Those are all requirements. I could take anyone off the street and say, do you think it's reasonable that we should allow AI systems to do those things? And they say, of course not. That's ridiculous. But the companies are saying, oh, it's too hard. We don't know how to stop our AI systems from doing those things. And as we do with medicines, we should say, well, that's tough. Come back when you do know how to stop your AI systems from doing those things. And now put yourself in the position of OpenAI or Google or Microsoft, and you've spent already 60, 80, $100 billion on developing this technology based on large language models that we don't understand. The reason it's too difficult for them to provide any kind of guarantee that the system is not going to cross these red lines, it's difficult because they don't understand how they work. So they're really making what economists call the sunk cost fallacy, which is we've already invested so much into this, we have to keep going even though it's stupid to do so. And it's as if if we imagine an alternate history of aviation where there were the aeronautical engineers like the Wright brothers who were calculating lift and drag and thrust and trying to find some power source that was good enough to push an airplane through the air fast enough to keep it in the air, and so on. So the engineer approach. And then the other approach, which was breeding larger and larger and larger birds to carry passengers. And it just so happened that the larger and larger and larger birds people reached passenger carrying scale before the aeronautical engineers did. And then they go to the Federal Aviation Administration and say, okay, we've got this giant bird with a wingspan of 250 meters, and it can carry 100 passengers, and we would like a license to start carrying passengers. And we've put 30 years of effort and hundreds of billions of dollars into developing these birds, and the Federal Aviation Administration says, but the birds keep eating the passengers or dropping them in the ocean. Come back when you can provide some quantitative guarantees of safety. And that's the situation we're in. They can't provide any quantitative guarantees of safety. They've spent a ton of money and they are lobbying extremely hard to be allowed to continue without any guarantees of safety.
Thank you. Coming back to cyber capability offenses, do you think you could really briefly paint us a picture of what the world would look like if we have AI-enabled strong cyber attacks?
So this is something that cybersecurity experts would be perhaps better able to answer, because I don't I don't really understand, besides sort of finding vulnerabilities in software, the typically the attacks themselves are pretty simple, right? They're just relatively short pieces of code that take advantage of some vulnerability. And we already know thousands or tens of thousands of these vulnerabilities that have been detected over the years. So one thing we do know about the code generating capabilities of large language models is that they're very good at producing new code that's kind of a hybrid of existing pieces of code with similar functionality. In fact, I would say of all the economic applications of large language models, coding is the one that maybe has the best chance of producing real economic value for the purchaser. So it wouldn't surprise me at all if these systems were able to combine existing kinds of attacks in new ways, or to basically mutate existing attacks to bypass the fixes that the software industry is constantly putting out. As I say, I'm not an expert, but what it would mean is that someone who's relatively inexperienced, coupled with one of these systems, should be able to be as dangerous as a highly experienced and well-trained cybersecurity or offensive cybersecurity operative. And I think that's going to increase the frequency and severity of cyber attacks that take place. Defending against the cyber attacks really means understanding the vulnerability. Like, how is it that the attack is able to take advantage of what's happening in the software? And so I think fixing them is probably, at the moment, in most cases, beyond the capabilities of large language models. So it seems like there's going to be a bit of an advantage for the attacker for the time being.
Thank you. So for the last questions before we pass the mic, so to say, to the audience, let's talk a bit about the safety summits, shall we? So the UK AI Safety Summit back in 2023 brought together, as you all know, international governments, leading AI companies, civil society groups, and experts in research to discuss the risk of AI, particularly frontier AI. As the first AI Safety Summit, it opened a new chapter in AI diplomacy, notably countries including US, China, Brazil, India, Indonesia, and others signed a joint commitment on pre-deployment testing. The UK and the US each announced the creation of their AI Safety Institute, and the summit generated support for the production of the International Scientific Report on the Safety of Advanced AI. So that was the first AI Safety Summit. When it comes to the second AI Safety Summit that happened in Seoul this year, co-hosted by the UK and South Korea, the interim international scientific report that I just mentioned was welcomed, and numerous countries, including South Korea, called for the cooperation between national AI safety institutes. Since then, we've seen increased coordination between multiple AI safety institutes with shared research initiatives and knowledge exchange programs being established. The summit also resulted in voluntary commitments by AI companies. That's the context. Given this context and these prior voluntary commitments, what would you consider to be the ideal outcome for the upcoming French summit, and how could it further advance international collaboration on AI safety? Difficult question again, I know.
So I consider the first summit, the one that happened in Bletchley Park, to have been a huge success. I was there. The discussions about safety were very serious. Governments were really listening. I think they invited the right people. The atmosphere was pretty constructive. Getting China and India to come to such a meeting on relatively short notice. I mean, usually a summit on that scale is planned for multiple years, 3, 4, 5 years in advance. And this was done in just a few months. I think starting in June was when the British Prime Minister announced that it was going to happen. And the people who worked on that summit, particularly Ian Hogarth and Matt Clifford, did an incredible job getting 28 countries to come to agree on that statement. And the statement is very strong, right? It talks about catastrophic risk from AI systems and urgent need to work on AI safety. So after that meeting, I was quite optimistic. In fact, it was better than I had any good reason to hope. I would say since then, industry has pushed back very hard. They tried to insert clauses into the European AI Act saying that basically a general purpose AI system is not, for the purposes of this act, an AI system. They tried to remove all of the foundation model clauses from the act. And I think with respect to the French AI Summit, have been working hard to turn the focus away from safety and towards encouraging government investment in capabilities and essentially the whole mindset has become one of AI as a vehicle for economic nationalism and potential for economic growth. And so in my view, that's probably a mistake because if you look at what happened with Airbus and Boeing, right? Boeing actually managed to convince the American government to relax the regulations on introducing new types of aircraft so that Boeing could introduce a new type of aircraft without going through the usual long process of certification. And that was the 737 MAX, which then had 2 crashes that killed 346 people. The whole fleet was grounded. Boeing may still be on the hook for lots more money to pay out. And so by moving from FAA regulation to self-regulation, the US has almost destroyed what for decades has been one of its most important industries. In terms of earning foreign currency, Boeing has been maybe the biggest single company over the years for the US. And Airbus continues to focus a lot on safety. They use formal verification of software extensively to make sure that the software that runs the airplane works correctly, and so on. So I would much rather be the CEO of Airbus today than the CEO of Boeing. As we start rolling out AI agents, so the next generation, talk about the personal assistant or the agent, the risks of extremely damaging and embarrassing things happening will increase dramatically. And so and oddly enough, right, France is one of the leading countries in terms of formal methods of proving correctness of software. Is one of the things that France does best, better than the United States, where we hardly teach the concept of correctness at all. I mean, literally, Berkeley, we are the biggest producer of software engineers in the world, pretty much, and most of our graduates have never been exposed to the notion that a program could be correct or incorrect. So I think it's a mistake to think that that deregulation or or not regulating is going to provide some kind of advantage in this case. So I would like the summit to focus on what kinds of regulations can be achieved. Standards, which is another word for self-regulation. I mean, that's a little bit unfair, actually. So standards are typically voluntary. And so let me try to distinguish two things, right? So there are standards like IPv6, right? The Internet Protocol version 6. If you don't comply with that standard, your message just won't go anywhere, right? You have to, your packets have to comply with the standard. Whereas the standards we're talking about here would be, well, okay, we agree that we should have persons with appropriate training who do an appropriate amount of testing on systems before they're released. Right? Well, if you don't comply with that standard, you save money and you still release your system. Right? So it doesn't work like an internet standard or a telecommunication standard at all. Right? Or the Wi-Fi standard or any of these things. And so it's not likely to be effective to say, well, we have standards for sort of how much effort you're supposed to put into testing. And the other thing is, companies have put lots of effort into testing. Before GPT-4 was released, it underwent lots and lots and lots and lots of testing. But then we found out that, you can jailbreak these things, with a very short character string and get them to do all of the things that they are trained not to do. And so I think the facts on the ground right now are that testing and evals are ineffective as a method of ensuring safety. And again, it's because how do you stop your AI system from doing something when you haven't the faintest idea how it does it in the first place? Right? And I don't know. I don't know how you stop these things from misbehaving.